Today, we're diving deep into a disease you might not have heard of, but that quietly devastates millions of lives. It's called lymphatic filariasis. It's a parasitic disease spread by mosquitoes, and it's often called a hidden plague. We're going to break down what it is, how it works, and what the world is trying to stop it.
Before we get into any of the science, I just want you to sit with that for a second. That one quote, it just cuts right to the heart of it all, doesn't it? The cost of this disease isn't just physical, it's social, it's emotional, it destroys futures.
All right, so let's get into it. First up, we're going to look at the problem itself. What exactly is lymphatic filariasis? What are its horrifying visible signs, like elephantiasis? And who are the tiny culprits behind all this suffering?
So the parasites that cause this are a type of roundworm called a nematode. Now, you might have heard of nematodes that live in the soil, but these are a whole different ballgame. These are what we call vector-borne, which is just a way of saying they need an insect, a vector, to get around. And in this story, that vector is the mosquito.
Okay, so there are a few of these worms that can infect people, but 3 of them are the main players. The biggest one, causing the most lymphatic cases around the world, is Wuchereria bancrofti. Then there's Brugia malaya, which does similar damage to the lymph system, mostly over in Asia. And it's worth knowing about a close cousin, Onchocerca volvulus. This one doesn't go for the lymph system, it lives under the skin and causes another terrible disease, river blindness.
So just how big is this problem? Well, get this. Right now, an estimated 800 million people are at risk of getting infected. That is a staggering number. Think about it. That's almost 1 out of every 10 people on Earth.
And that's just the number of people at risk. The reality is there are at least 120 million people who are already infected, right now, with these parasites living inside of them. A lot of them don't even know it yet.
So how does this actually happen? How does a tiny worm get from a mosquito into a person and cause so much trouble? Let's get into the cause and walk through the parasite's really fascinating and pretty complex life cycle.
It's a 2-host journey. It all starts when an infected mosquito lands on you for a bite. It deposits these tiny infectious larvae, called L3 larvae, right onto your skin. They're so small they crawl right into the bite wound. Once they're inside you, you're what's called the definitive host. They travel to your lymphatic system and grow into adult worms. Those adults then produce millions and millions of live baby worms called microfilaria. And these little guys circulate in your blood, just waiting for the next mosquito to come along, bite you, and drink them up with your blood. Inside that mosquito, the intermediate host, they grow up from the L1 to the L3 stage, and just like that, the mosquito is ready to infect someone else.
Now, you'd think finding these parasites inside someone would be easy, right? Well, not so much. Let's talk about the complications, because detecting this hidden enemy is a huge challenge, partly because of the worm's incredibly clever behavior.
This is where it gets really wild. It's called microfilarial periodicity. The parasite has literally timed its schedule to match the mosquitoes. So for the periodic form, those little microfilaria swarm into the blood near the skin at night between about 10 p.m. and 4 a.m., exactly when night-biting mosquitoes like Culex and Anopheles are out for a meal. Then you've got the subperiodic form, which peaks during the day to line up with day-biting Aedes mosquitoes. It's an amazing evolutionary trick, but it makes diagnosis a nightmare. You have to draw blood at exactly the right time, or you'll miss them completely.
And because of that challenge, our diagnostic toolkit has had to evolve. We started with the old-school method, a thick blood smear on a microscope slide, which of course was totally time-dependent. Then we developed concentration techniques, like nucleopore filtration or Knott's concentration, to make the worms easier to find. But the real game changer is the immunochromatographic test, or ICT. It's a rapid card test that detects worm antigens, and you can use it any time of day. Now we even have tools like antibody tests to see if someone's been exposed in the past, and something called molecular xenomonitoring, where we actually test the mosquitoes themselves for the parasite's DNA.
The symptoms can be all over the map. A lot of people have it for years and are asymptomatic. Maybe the only sign is something like hematuria, which is blood in the urine. But as it gets worse, it can cause incredibly painful inflammation of the lymph vessels, that's lymphangiitis, and the lymph nodes, that's lymphadenitis. It can cause severe swelling, like a hydrocele in men, and eventually, it can lead to the devastating, disfiguring condition we call elephantiasis.
Okay, that's the bad news. But there is a global counterattack happening. So let's shift gears and talk about the solution. What are the treatments, and what are the strategies being used to fight back against this disease?
The charge is being led by the World Health Organization through their global program to eliminate lymphatic filariasis, or GPLOF for short. The main goal is simple:
interrupt transmission, stop the parasite from getting from person to person. And the key weapon in this fight is something called mass drug administration, or MDA, where entire at-risk communities get preventative medicine all at once.
Which, of course, leads to a really good question. If we have the drugs to treat this, why not just hand out the same pill to everybody? Why is it so complicated?
Well, here's the kicker. You have to know what other parasites might be in the area. See, if a patient is also co-infected with Onchocerca vorvulis, the river blindness parasite, giving them the standard drugs can cause a massive and dangerous immune reaction as the worms die off. It's even worse if they also have Loa loa, another filarial worm. In that case, the drugs can cause a potentially fatal brain swelling or encephalopathy. So what do? Well, the solution is just genius. You use an antibiotic, doxycycline. It doesn't actually kill the worm directly. Instead, it kills a tiny bacteria that lives inside the worm, called Wolbachia, which the worm needs to survive. So the worm dies off slowly and safely.
And this quote from Dr. William Campbell, the guy who won a Nobel Prize for discovering ivermectin, one of the key drugs we use, it just says it all. Science has a moral duty to not forget about these diseases, to not leave people behind just because they live in the developing world.
But this brings us to what might be the most crucial part of this whole story. Stopping the parasite is one thing, but what about the people who are already living with the damage? We have to talk about the human factor.
Just listen to these voices. The person who couldn't even go to the hospital because of the stigma, afraid their family would be shunned. The tailor who lost their entire income because customers were repulsed by their leg. The coconut climber, forced to keep working despite agonizing pain from a hydrocele. This is the real, daily toll of the disease.
And this is the vital takeaway. The severe physical damage, the elephantiasis, it's permanent. It's non-reversible. Even if you kill every single parasite in a person's body, the damage is already done. That's why morbidity management and disability prevention, MMDP, has to be a central part of any of these programs. It's not enough to stop the infection. We have to care for the people who are already living with the scars.
And that leaves us with this final, really powerful thought. Can we really claim a program is a success if it just stops transmission, but turns its back on the millions already suffering? True success, true elimination, can't just be about killing a parasite. It has to be about restoring dignity, health, and hope to every single person affected.